So what we're learning about today is what we refer to as the locus definition for a parabola. Locus. Does anybody know what the word locus means? A locus is just basically a set of all points that fit a certain situation. So a lot of times what they do is they'll say, okay, we have a point here. They want to know the locus of all of the points that are a certain distance from that. So what ends up happening is around just one point, it creates a circle. All those points in that circle are the same distance from here. So if we were to measure it, this distance would be, I don't know, we'll call it like 4. And if you measure over here, that distance would be 4. So it's all equidistant from that one point. And then your locus changes a little bit depending on what your shape is. So like for example, if we have two lines, our locus would be right in the middle of them because that's the only point in time you could be exactly the same distance from both lines. So as I was saying, the locus changes depending on what your picture is. Right down here in between the middle of these two lines, that's the only time you're going to be the same distance from both of them. You can't be over here because then you're closer to this line than you are to that line. The locus is always exactly the same distance from both things. So, taking a look at our notes, what they're doing is they're giving us a focus. Your focus is just a point. And they're giving us a directrix, which is a line. So they want to find all of the points that are equidistant from that line and that point. And what ends up happening is it creates a parabola, which is our quadratics that we've been dealing with. So what they want us to do is they want us to create the equation of that parabola that is created by being equidistant from that point and that line. So right here is the formula we have to use. You're going to have to memorize. That's not one they're going to give us. We got to memorize that one. So y equals 1 over 4p times x minus h squared plus k. So now h and k, we have been dealing with those before. That's the same exact thing we've had before. hk is your vertex. So we'd have to go through and we would have to find the vertex of our parabola that is created. The thing that's new to us is that p is the distance from the vertex to the focus. P is also the distance from the vertex to the directrix. So it doesn't matter which one you're looking at. P is the distance from your focus to your vertex or from your vertex down to your directrix. So your vertex is right there in between the two of those. So down here, this is all information we can get from our equation. So our vertex is the point hk. That's not new. We've been dealing with vertex being hk with our vertex form. Our axis of symmetry is x equals whatever h is. So whatever your x value from your vertex is, that's your axis of symmetry. Your focus, remember your focus is the point, is h comma k plus p. So whatever your h value is from your vertex, the focus has that same number, and then it's the k plus the p, which p is the distance between your focus and your vertex. And then the directrix is the line y equals k minus p. So remember your directrix is below your vertex, unless it's an upside down parabola, but we'll deal with that one in a minute. So a parabola has a focus of 0, 7 and a directrix of y equals 3. They want us to determine the equation of the parabola using the locus definition. So first thing we should do over here is rewrite our locus definition. So y equals 1 over 4p times x minus h squared plus k. So the things we need to know our vertex, and we need to know the value of p. So a couple ways we could do this. One way is you could sketch yourself a little picture. So here's my x and my y axes. My focus is up here at 0, 7. You don't have to be exact. We're just going to kind of estimate a little bit. That's up there at 0, 7. Our directrix is at y equals 3. So I'm going to kind of sketch that in there. So our vertex is going to be halfway in between those two things. So how many units are in between both of them? 4. So halfway would be where? So right here at 0, 5, that would be our vertex, because it's halfway between that focus and that directrix. And as I was saying above, your x values for your focus and your vertex, that's always going to be the same. So that's how I knew that was a 0. And then 5 was going to be in between my 3 and my 7. So now our p value is the distance between the focus and the vertex, so our p is a 2. It's also the same distance from your vertex to your directrix, so it really doesn't matter which one you use. It's always going to be the same distance. So now we can plug it in. Y equals 1 over 4 times 2, because our p value is a 2. And then x minus 0 squared plus 5. So we just have to clean it up a little bit. 4 times 2 gives me 1/8. X minus 0, well, I don't really need the parentheses because it's minus 0, so I can just write x squared. Or you could keep writing x minus 0 squared, and that's fine. Plus 5. So that's one way of doing it, making that little graph, and then you can find your information that you need from there. Another way of doing it is what some people do is in order to find the value of k, which if you remember in your vertex, k is your y value. So another way of doing it to find that k value is you could take the average of your focus and your directrix. So the y value of your focus would be 7 plus the 3 from your directrix. And then divide it by 2, take the average of them. So that would give me a 10, divided by 2 would give me a 5. So that's how we would know that our vertex is the 0.05, because it still has the same x value as your focus. K value we got by taking the average, so it would be 5. Your p value would be your focus minus your vertex value that we got, so our 7 minus 5, so you'd get your p is 2. So then again, you would still fill it in, you would get the same equation. So you can either make yourself the picture, which personally I'm kind of a big fan of the picture because I've always been a visual learner my whole life, or you could actually do the algebra out on the side. So whichever way you guys prefer. So let's take a look at the next one. We have determined the equation of the parabola whose focus is 4, 1 and whose directrix is the horizontal line y equals -3. So which way do we want to go about it? Do we want to make the picture or do the averaging stuff? Alright, we'll go with picture. So 4, 1 is going to put me somewhere over there for our focus. Y equals -3 is going to be somewhere down here. So how many units are in between these ones? 4. So that means our vertex is going to be right about here at 4, -1. So then it's 2 from the focus and 2 from the directrix. So that means our vertex, as we just said, is 4, -1. Our p-value is a 2. So then again, writing the formula, I recommend writing it each time you're going to use it, only because it will help you commit it to memory. So just keep writing it over and over again, it'll help you memorize it. So y equals 1 over 4p times x minus h squared plus k. And then let's plug in our numbers. So y equals 1/8, because I would have 4 times my p-value of 2, so 4 times 2 gives us 8. X minus 4 squared minus a 1, because my k value this time was negative, so it would be minus the 1. So now sometimes they may ask you to find pieces of information from the equation that you're given. So one way is to take your equation, if for some reason it's not written in the way that we have it written up there, you just want to rearrange it so that it is written that way. So what I would do first is divide by the 4. So I'm going to write that over here. So I would have 1/4 x minus 3 squared equals the y plus 2. So then I would want to subtract that 2 over. So I get 1/4 x minus 3 squared minus 2. Now again, I put that 1/4 out in front because I couldn't actually divide the stuff in the parentheses since it's squared. And there was a 1 out in front before that wasn't written there, so I just made that 1/4 out in front, and now it looks exactly like our formula. So our vertex would be the point 3, -2. There's my h, and there's my k from our formula. Our axis of symmetry, as I have written on the front, would just be x equals whatever that number is from your vertex. So x equals 3 is our axis of symmetry. What we need to figure out next is our p-value, because figuring out our p-value will help us find our directrix and our focus. So what you have to remember from our formula, this value down here equals 4p. Yep, so p is going to equal a 1, because I would divide by 4, and my p-value is a 1. So that means our focus is only 1 unit above our vertex. So that makes it 3, -1, because I would take this and add 1 to it. So that makes it 3, -1 for our focus. And your directrix would be 1 unit below the vertex. So that would be y equals what? -3, because we were at -2 for our vertex. So just going 1 unit lower, our focus would be at 3, -1. Or I'm sorry, would be at y equals -3. Now the other method, if you don't feel like rearranging the formula, is you could memorize the information from the formula written like this. So as I said, you don't have to rearrange anything. So if you're looking at this, our vertex, h is with your x, k is with your y. Both of them you would have to change the signs of. So that would make our vertex 3, -2 again. Whenever it's in parentheses, when you take that number out of the parentheses, you got to remember to change the sign. So our axis of symmetry would be x equals 3. It's the same value as your x value from your vertex. Again, we would have to, in order to do our directrix and our focus, we got to find our p-value. So when your formula is written this way, whatever number's in front of the parentheses of your y, that's what you set equal to your 4p. And then you can solve for p. So we still have a p-value of 1. So that means our focus is 1 unit up from our vertex, and our directrix is 1 unit down from your vertex. So you still get the same numbers. So again, it's just a preference. If it's easier for you to just keep rewriting it into the one form, then go ahead and do that. Rearrange the formula. If this one makes sense to you, then by all means go ahead and do that. Alright, so we got a multiple choice question here. What are the vertex, focus, and directrix of the parabola with this given equation here? Well, can we really tell from that equation there? No. So what do you think we should do? You can't skip it. We don't want to factor. If we look up here at our vertex form, like right over here, does this look kind of familiar to another form we've done before? Yeah, which one? That's our vertex form. We were dealing with our vertex last time. It looks very similar to your vertex form. It's just got that extra little 4p thing there. So if we go down here, what we want to do is we want to take this equation. We're going to do our completing the square, and we're going to put it in vertex form. And then we'll be able to answer all those questions. So I'm going to subtract my 15 over first. So y minus 15 plus a space equals x squared minus 6x plus a space. We'll see. So what's our number that's going to go in the space? 9. So we get y minus 6 equals x minus 3 squared. And then what do we do with our 6? Yep. So automatically, right away, yeah, we can eliminate choice B. Our vertex is not going to be the 0.36. What would our vertex end up being? I'm sorry, it's not going to be 6.3. It's going to be 3.6. So which one does it end up being? It would be A. Now, when we are in vertex form, I just want to show this to you. What number do we have out in front here that's not written, but it's always there? 1. So you can still find your p-value. 4p would equal a 1. Divide by 4. Our p-value for that one is 0.25. So that means your focus is 0.25 above and your directrix would be 0.25 below, which is why we have those decimals in there, because our p-value is a decimal this time. So it still works the same way. Let's try a few more questions. So here we have the directrix of the parabola given there has the equation y equals -6. Find the coordinates of the focus of the parabola. So again, I'm a big fan of the picture, so I'm going to go ahead and start drawing myself a picture. I know my directrix is down here at y equals -6. So let's see what else we can figure out. What would be our vertex from our equation? Close. Close, close, close. You just have it backwards. 4 goes with the x. -3 is our y. So that means over here at 4, -3, I'm going to estimate That's our vertex. So how many units are in between here? 3, because we go -6, -3. There's 3 units apart. So I got to go 3 units higher than my vertex. And that's going to be our focus. So that would be the equation, or I'm sorry, the point for 0. It's got the same x value as your vertex. It's just it's 3 units higher, so it's at 0. Alright, which equation represents a parabola with a focus at 0, -1, and the directrix at y equals 1? So let's start sketching a picture. So y equals 1, here's my directrix. And our focus is at 0, -1. So what happens is this time your focus is on the bottom. It has never been on the bottom so far. So since the focus is actually below the directrix, that means your p-value is going to be a negative number. If the focus is below, that means your p-value is a negative. That's how we get our negative parabolas there. So our vertex would be right in the middle. So our vertex would be the point 0, 0. So what is our distance between our vertex and our focus? 1. So that means our p-value is going to be a -1. So if we're looking at these equations up here, D and C we can knock out right away because those numbers in front of your y are positive. So that means those would have positive p-values. We don't want a positive one. We want a negative one. So we got it narrowed down to choice A or B. Which one do you think it's going to be? B. Very good, because the P's a -1, and remember that's 4 times your P. So it's going to be choice B. A represents a P value that would have been -2 because it was a -8 out there.